Welcome to the Implicit Differentiation podcast. I'm going to do 2 problems in this podcast. I'm going to skip one problem that's in your notes. I'm going to do that in class. It takes a little bit longer, and I kind of have to need to change screens, and it'll be easier for you to follow in class, I think. But these 2, no problem. All right, so we want to find dy dx for x squared y plus xy squared equals 2x. We see we have 2 product rules. So remember, the product rule is the first times the derivative of the second. All right, so for x squared y, that would be the first x squared times the derivative of the second, which is dy dx. And I have a random box there I can't seem to get rid of. And then plus the, there we go, plus the second y times the derivative of the first, which is 2x. All right, now you're going to do the same thing for the second product there. So we got the first x times the derivative of the second. Derivative of y squared will be 2y dy dx plus the second times the derivative of the first. So the derivative of x is just 1, so we'll just have a y squared there. And then derivative of 2x is just 2. All right, so now we need to move everybody that does not have a dy dx to the other side. So we have x squared dy dx plus x. Let's clean that up actually a little bit. That looks a little messy, having the 2 after the y. All right, so x squared dy dx plus 2xy plus 2xy dy dx plus y squared equals 2. All right, now we'll move the terms. So we have x squared dy dx plus 2xy dy dx equals, we have a 2, we have now a minus 2xy and minus a y squared. We'll factor out the dy dx. So dy dx times x squared plus 2xy equals 2 minus 2xy minus y squared. Divide both sides by x squared plus 2xy. And we have our derivative. Dy dx equals 2 minus 2xy minus y squared all over x squared plus 2xy. When these become difficult when you have a lot, when the algebra becomes more difficult, when you're simplifying is more difficult. So this was an easy simplifying, so it was an easy derivative. We'll look at one more that's not too difficult either. All right, so we want to take the derivative of x plus y squared plus y equals 2. All right, so we have a bit of a chain rule there. All right, so we have to take the derivative of the chain. So derivative of blop squared is going to be 2 blop. Right, so that will be 2 times x plus y times the derivative of the inside part. All right, so the derivative of x is going to be just 1. That's just a sum here, so we can take the derivative of each term separately. The derivative of y is dy dx, right, plus derivative of y there is going to be dy dx. And then derivative of 2 is 0. All right, so now we need to multiply here and kind of get this to where we can clean this up. We got dy dx's mixed in with terms without dy dx and all kinds of stuff. All right, let's FOIL first, right, and then we'll distribute the 2. So we have 2 times, right, x times 1 is going to give us x. X times dy dx will be plus x dy dx, and we leave off the inner terms there would be plus y, and then plus y times dy dx is going to be y dy dx. So all I did is distribute there. We'll distribute that 2 in a moment. Plus dy dx equals 0. My dy's are starting to look like ay's. All right, so now we'll distribute the 2, and I was trying to make that look more like a D, and it did not end up in the right spot. And of course, it's stuck there. Come on, don't be so slow. All right, well, you know that's a D, D, right? There we go, close enough. All right, so we'll distribute. We have 2x plus 2x dy dx plus 2y plus 2y dy dx plus dy dx equals 0. Now everybody without a dy dx is going to move to the other side. So we have 2x dy dx plus 2y dy dx plus dy dx equals negative 2x and negative 2y. And now all we have to do is factor out the dy dx. And we have 2x plus 2y plus 1, right? dy dx divided by itself is just 1, equals negative 2x minus 2y. And then we'll divide both sides by 2x plus 2y plus 1. Right? 2x plus 2y plus 1. Right? And so that's going to give us dy dx equals negative 2x minus 2y all over 2x plus 2y plus 1. And now we have our derivative. Right? Not too bad. Those two didn't take me too long, but the next one third one would take me a while. So I don't know I want to do that. This I'm going to post. Super easy problems there. Nothing too difficult for you. So 1, 2, 3, and 4 questions for you. All right. Let's see if I want to do any more. The one I wanted to skip is the one below. That's going to take a little longer. We've got a 2xy. Let's do this one, the equation of the tangent line. Square root of x plus square root of y minus 1 equals y. And we're going to write the equation at 9, 4. Okay, so that will be the last one that we do. All right, so let's rewrite these with rational exponents. So we have x to the 1/2 plus y to the 1/2 minus 1 equals y. It's kind of like the one I skipped, except this is a lot simpler. So this is a better one to do first. All right, so derivative of x to the 1/2 would just be power rule 1/2 x to the negative 1/2. Derivative of y to the 1/2 would be almost the same thing, except it's going to be a y to the negative 1/2, and it's going to be a dy. Oops, why did I write it next to it? dy dx. Minus 1 equals dy dx. We already have 1 dy dx on that side. Let's move the other term. So we have 1/2 x to the negative 1/2 minus 1 equals dy dx plus 1/2 y to the negative 1/2 dy dx. Got a little bit of simplifying there with the negative exponent. Let's factor out the dy dx though first. So we have 1/2 x to the negative 1/2 minus 1 equals dy dx times 1 plus 1/2 y to the negative 1/2. Right, so we're going to divide by 1 plus 1/2 y to the negative 1/2. 1 plus 1/2 y, oops, to the negative 1/2. And that's going to give us our derivative, except it's going to need some cleaning up because you see we got 2 negative exponents there. All right, so we have 1/2 x to the negative minus 1 over 1 plus 1/2 y to the negative 1/2 equals dy dx. All right, so now we need to clean this up a bit. Let's clone this page so that we could, oops, clone page. Okay, there we are. Move pages there. Come on. There we go. All right, so we're going to get rid of all of this. Or try to. Right, let's rewrite these as let's simplify the negative exponents and then clean up the negative exponents. All right, so that would be 1/2 square root of x, right? I'm just going to leave it just the way it is, then we'll clean everything up. Minus 1 all over 1 plus 1/2 square root of y. And that's, oh, excuse me. Yes, it's in the denominator. You can't see it too well in that one. I almost thought I didn't put it in the denominator. 1 over 2 square root of y equals dy dx. So let's multiply see if you simplify it like this, now you can see what to do. Multiply everybody by a 2 square roots of x and a 2 square roots of y. So I'm going to do that one. And this one, 2 square roots of x and 2 square roots of y. Oops, oh, that's really sloppy. And 2 square roots of x, 2 square roots of y. Oops. Well, now I tried to close that and it looks worse. And 2 square roots of x, 2 square roots of y. Now I don't have to worry about the dy dx. Now because I've multiplied everybody by 2 square root, everybody on one side, numerator and denominator, essentially I've multiplied by 1 over 1. Because 2 square roots of x, 2 square roots of y over 2 square roots of x, 2 square roots of y is 1 over 1. All right, so now we're going to cancel these things and then I'll clean that up. So this will cancel there. And so that's just going to be a 2 square roots of y. And this is going to be minus 2 square roots of x times 2 square roots of y all over. And actually, maybe we're going to be able to cancel out these 2's, or factor out the 2's. And now we have a 2 square root of x times 2 square roots of y. Oops. And then the square roots of y will cancel here. So that's going to give us plus 2, oops, I'll write black here. Right, so plus 2 square roots of x, 2 square roots of y. All right, so now do you see everybody has a 2 we could factor out? All right, so there's a 2. I can factor out one of those 2's. There's a 2. There's a 2. Right? That would be 4 square roots of x, y. Let's just factor out the 2. All right, and so now, oh, equals dy dx. Now that's just going to be square root of y minus 2 square roots of x square root of y. And actually, let's make that even simpler. That does not need to be 2 terms. That could be 2 square roots of x times y. There we go. Now that one has 2 2's. That's why it still has a 2 left. And this one has 2 2's. So 2 square roots of x times y, and then plus 2 square roots. Oh, why don't we add those things together? X, y, which we could, equals dy dx, which we could add together because they're the exact same. Oh, wait. No, we didn't. Did we not cancel something out? 2 square roots of y. Why is there a 2 square roots of y there? There should not be a 2 square roots of y in the denominator. Right? Let's get rid of the y. Okay, there we go. I crossed it off and I don't know, it just decided to hang around anyway. There's our derivative. We were asked to find the slope of the tangent line. Let's do that real quick. So our slope, so dy dx, we got to evaluate at 9, 4. So that's going to give us, need a bit more space. Oh, I should have wrote smaller. Equals square root of 4 minus 2 square roots of 9 times 4 all over 2 times 9 times 4 plus 2 times square root of 9. And that will simplify to That'll be 2 minus, 9 times 4 is 36, right? And 2 times, well, I'll write it out. I don't want to lose anybody. Okay, so 2 square roots of 36 plus 2 square roots of 9. Now I'm going to simplify it. All right, is 2 minus, that's 6 times 2, so that's 12, over 2 times 6 is 12, plus 2 times 3 is 6, so that's going to just give us negative 10 over 18, which is going to reduce to negative 5/9. That's our slope. And then the tangent line, of course, easy cheesy at this point, since we did all the work, is just, I'm going to leave it in point slope form. Y minus 4 equals negative 5/9 x minus 9. There we go. And actually, that wouldn't even be that bad to simplify out. If we were to simplify it out, that would be y equals negative 5/9 x plus 5. Those 9s will cancel. And then plus 4. So in slope-intercept, our equation is y equals negative 5/9 x plus 9. There we go. So pretty simple, right? I think the hardest thing was the simplifying out. That's where it pays to remember you can multiply. When you got a rational expression, you can just multiply by the same thing over itself, and you're just multiplying by 1. And that's the end of this podcast. All right, so see you later. Bye.